In order to enhance the player experience, we hope to simulate the effect of a high-end indoor basketball court and hang 2 display screens on the left and right of the basketball stand so that players can observe whether the goal is scored in all directions when shooting. Here, we need to apply multiple cameras. First, find the backboard node of the basketball stand. Right-click, select Camera, and add a camera node near the backboard. Adjust the position of the camera so that the camera is located in front of the left side of the backboard. Adjust the rotation angle of the camera so that the camera shoots the basket from the left front. Adjust the field of view parameter value and clipping planes parameter value to achieve a close-up photography effect of the basket. Copy the camera node just now to get a new node. Change the camera node just now to camera left. Change the copied camera node to camera right. Adjust the parameters of camera right. First, change its X coordinate to the opposite of the previous one. Then restore its rotation value as in X, Y, and direction to 0. First rotate camera right around axis by -90 degrees. Then rotate camera right 40 degrees around axis. Then change the rotation value of camera left around axis to 0 degrees. Thus make it symmetrical with the other camera round basketball hoop. Next, we need to render the images shot by multiple cameras in the game in layers. So, we need to set the depth property. The depth property means the order in which the camera renders the game world content to the screen. The smaller the property value, the earlier it is rendered, so the camera with a larger value will be drawn above the camera with a smaller value. We set the depth value of both camera left and camera right to 2. Adjust the viewport property of the camera component on the camera right node. Make the size of the captured image and the position on the screen more reasonable. Copy the property value of the camera component on the camera right node. Paste it to the camera component on the camera left node. Modify the X value in the viewport property of the camera component on the camera left node to make it roughly symmetrical with the other image. Finally, change the clear flags property value of camera left and camera right to depth. Run and observe the effect. We can adjust the position of the camera component in the running state. After adjustment, copy the property value of the camera component. Then exit the running state. Paste it to the camera component of the node that has just been adjusted. Run again and see the effect. Perfect. However, before shooting, I want the left and right screens to appear because they block my view of the handsome men and beautiful women who may pass by. I only hope that these two screens will appear after the basketball is shot. When the basketball returns to the idle state, the two screens disappear automatically. Just like the warm men in this world, they always come quickly when you need them and leave quietly when you are tired. What to do? You see, in the running state, we cancel the camera node mounted on the backboard, and the captured picture disappears. When the program is running, we need to set the display or hiding of these two camera nodes according to the state of the basketball. The state of the basketball is saved in the basketball controller class, which is mounted on the basketball node. If we write a script mounted on these two camera nodes, and then associate the basketball node in the script, we need to make the basketball stand into a prefab later, and the associated basketball object may be lost. Obviously unreasonable. Similarly, if the camera on the backboard is associated in the basketball controller script, the basketball stand will be made into a prefab later, and multiple basketball stands may be generated, which will also cause problems. And later we are also going to let the player walk and turn. If the player turns 180 degrees and shoots at the basketball hoop in the other half of the court, the pictures taken by the two cameras on the left and right sides of the basketball stand in the other half of the court should be displayed. Therefore, it is definitely unreasonable to bind each other in the script here. Some students thought of event subscription and publishing. Event subscription and publishing can indeed achieve decoupling and solve the above problems. However, there are two basketball stands in the same basketball court. The two basketball stands subscribe to the shooting event at the same time. When the shooting event is released, which basketball stand, S camera, S picture is displayed. This problem is not easy to solve. It is impossible that when shooting at the basketball hoop in the north, the camera on the basketball hoop in the south is displayed. Some students also said that a distance can be set in the subscription event of the basketball hoop. If the distance between the basketball and the backboard is less than this value, the camera on the basketball hoop will be turned on. However, in this case, do we still need to obtain the external node basketball? Similarly, after the basketball hoop is made into a prefabricated body, it will also be difficult to obtain external nodes. What's more, there may be multiple basketballs in the future. How to solve these problems? Let's think about it. In fact, the solution we used when implementing the basketball goal logic before can be used for this problem. Has anyone thought of it? When we were doing the basketball goal logic, we added a trigger to the net. When the basketball collides with the basketball in the net, the goal score is recorded. In the same way, can we also add a trigger in front of the backboard? When something collides with it, turn on the cameras on the left and right of the backboard, and turn off the camera on the backboard when the touch object leaves? Isn't this a solution? First, right-click in the hierarchy window on the left, select 3D object, sphere, and create a new sphere node. Drag it under the previously edited basketball stand node, and place it above the backboard node. Change the name of the sphere node to camera switch to mark the camera switch. Adjust its position to the center of the basket. Switch to different perspectives to make sure it just covers the basket. Then scale this node. Make it just cover the backboard. After testing, the scale value is between 2.5 and 3. Switch to different perspectives to observe more reasonably. Our goal is to ensure that the camera switch is triggered when the basketball touches this sphere. Next, we add a sphere collider to this node. Check its trigger to use it as a trigger. Then cancel its mesh renderer. After that, you need to write a script and hang it on this node to realize the opening and closing of the left and right cameras of the backboard. Create a new TypeScript file in the scripts folder and name it backboard camera controller to mark the camera control script on the backboard. Drag this script to the camera switch node just now. Double-click this script to open it. We need to trigger an event when other colliders start to collide with the collider of camera switch and turn on the cameras on the left and right of the basketball stand. Therefore, we need to add the integrator method to this class with a parameter of collider type. This method will be automatically called by the game engine when other colliders collide with it. In addition, we need to trigger an event when other colliders are out of contact with the collider of camera switch and turn off the cameras on the left and right of the basketball stand. Therefore, we need to add the onTriggerExit method to this class with a parameter of collider type. Please note that the keys I pressed will be displayed in the lower right corner of my screen. In Xcode, we can select the onTriggerExit method just now, and then press Alt plus Shift plus down arrow to copy the selected code. Change the obtained method to onTriggerExit. When the collision occurs, we need to manipulate the two camera nodes on the left and right of the backboard, so we need to declare two variables to bind these two nodes. In the editor, bind the relevant camera. Write a method to turn on and off the camera. Then, turn off the camera in the onStart method. Turn on the camera in the onTriggerExit method. Turn off the camera in the onTriggerExit method. Press the shortcut key Ctrl plus S to save. Run and test, and find that after the basketball is scored, the moment it bounces off the ground will cause the camera to turn on and off in a short time. The game screen will have a flickering effect, and the user experience is not friendly enough. We can fine-tune the collision body, scaling value on the camera switch node just now in the running state, or pull it up a little higher. Then after the test passes, copy the transform attribute value of the camera switch node. After exiting the run, paste it to the transform of the camera switch node. After testing, we found that it is more appropriate to set the scaling value of the camera switch node to 2.5. Save and test. After passing the test, we can make this basketball stand into a prefab. Delete the previous basketball stand prefab. Make a new basketball stand prefab. Untie the previous node. Delete another basketball stand. Generate a new node using the new basketball stand prefab. Untie this node. Change its Z value to 10. Change the rotation value around the Y-axis to 180 degrees. At this point, the logic of our fixed point free throw is basically complete.